Hello, chemistry students. Today I'm going to introduce you to stoichiometry problems. Stoichiometry can be defined as the relationship between substances that react in a chemical reaction. And usually this relationship is expressed as a ratio, so we're going to use that in order to solve some problems. So one thing that you need to remember whenever you start solving stoichiometry problems is that you have to make sure that your equation that you're beginning with is balanced. And I wrote it in blue on the sheet here. I can see at a glance that my hydrogens and my potassiums are a little bit out of whack, so I want to go ahead and balance those. I will do that by putting a 3 in front of hydrochloric acid or hydrogen chloride on my product side. That makes my hydrogens balanced, but now my chlorines are imbalanced. So I'm going to add a 3 coefficient to my potassium chloride on the reactant side, and now I have a balanced equation. Now, you balance equations not only to satisfy the law of conservation of mass, but also to ensure that you know how much of each reactant you need in order to generate products. And the coefficients tell you how much you need. Because I have no coefficient in front of hydrogen phosphate, this means that I have 1 mole of hydrogen phosphate, and I'm combining it with 3 moles of potassium chloride, and I'm producing 1 mole of potassium phosphate and 3 moles of hydrochloric acid. So the coefficients tell you how many moles there are. And in some other videos, I'm just going to give you an example, but you already know this. You can calculate how much 3 moles of potassium chloride weigh in grams, and you can calculate how much 15 moles of something weighs in grams. And that's an important thing to be able to do, because in a lab setting we don't have scales that measure moles, we have scales that measure grams. So we need to convert moles to grams all the time. So that's something that you're going to become very proficient in if you aren't already. Okay, so let's take a look at solving a problem here. So how many moles of potassium phosphate can I produce if I start with 8 moles of potassium chloride and plenty of hydrogen phosphate? So the part that says plenty of hydrogen phosphate just means that you have this unlimited supply, and that hydrogen phosphate isn't going to limit the amount of product that you can make. It's kind of like saying I only have enough sugar to make 2 dozen cookies, but I have enough chocolate chips to make 5 dozen cookies. And so then the sugar would kind of limit how much you produce. But we're going to talk about that later also. But for now, just focus then. I'm going to just cross out the part about plenty, because this is something that we don't really need to worry about right now. What we're focusing on is the relationship, though, between potassium chloride and potassium phosphate. And really what we're saying is how many moles of potassium phosphate is equal to 8 moles of potassium chloride. But we're not going to write it like this. We're going to write it like a proportion. So let's redo this. And again, it doesn't matter what you put on top. It just matters how you set up your second proportion. So 1 mole of potassium phosphate equals 8 moles of potassium chloride. So how are we going to figure this out? We're going to write out something called the mole ratio. And the numbers that I put here are going to come from the problem above. So just like we did in the conversion proportions, you're going to carry over moles, your units on top, over to the side. And before, I wasn't real picky about you writing down the formulas, but when you do this, you want to make sure that you do so that you don't get confused. And since I have moles of potassium chloride on the bottom, I'm going to shift that over and just copy it to moles of potassium chloride on the bottom on the other side. Okay, now comes the part where I use the numbers from my equation. Well, how many moles of potassium phosphate do I have in my equation? Here's potassium phosphate, and I have no coefficient in front, so that means that I have 1 mole of potassium phosphate. And in my balanced equation, how many moles of potassium chloride do I have? Here's potassium chloride, and here is my coefficient. So I have 3 moles of potassium chloride there. So now, in order to solve for x, I need to cross multiply and divide. So x times 3 is 3x, and that's going to equal 8 times 1, which is 8. To solve for x, or to isolate x, I need to divide both sides by 3. And x is equal to 2.7. And now, because I have my variable next to moles of potassium phosphate, a minute, let me just circle that again, because I want to make sure that I include my potassium phosphate. And this, folks, is your final answer. All right, I hope that you found this video helpful, and there is more to come. Thanks for watching.